Thank you. Thank you. Hi, everyone. Idan Plotnik. I'm the founder and CEO at Apiiro. Formerly, I was the GM for software engineering at Microsoft, and I felt the pain of embedding application security into the development lifecycle. And today, we're going to talk about the new acronym, ASPM. Who knows what ASPM means? No one. Okay. Application Security Posture Management, new acronym from Gartner. Let's start first to understand the evolution of application security. It's all started from the siloed tools that everyone deployed in their organization. The SaaS, the DaaS, the SCA. They were reactive, created a cacophony of contextless alerts and a long backlogs that required manual triage. Then, after that, came the orchestration piece, the ASOC, application security, not the buzzword, application security orchestration and correlation, and developer-centric tools. What happened? They took all the alerts from all these tools and just shift them left to the development teams without any context. This created a lot of friction between development teams and security teams. And today, we're in a new era in the application security space. We need one unified contextual platform that takes the visibility, prioritization, and remediation in one platform. Based on Gartner, by 2026, you can see that more than 40% of organizations worldwide that are developing proprietary software will adopt ASPM to identify and fix risks in their applications using ASPM. So let's take one step, deep dive into what it means context, okay? Why the AppSec teams are lacking the context, the actionable context they need, and what it actually means. So let's go one by one. Let's say I deployed a SaaS tool. The SaaS tool identifies a SQL injection on a line of code, but this SaaS tool doesn't understand that the SQL injection is related to an API in the code. Someone needs to connect these dots. Then I deployed my SCA tool. So I found an RCE, remote code execution, on an open source dependency. And then I found an abnormal developer behavior. Someone committed code to a repo that he never did before, or to languages that he never touched before. And then we have a breach into the CI/CD pipeline, like the SolarWinds case. But guess what? These are all siloed alerts that are behind the scenes are connected. So I have a data model in my code that exposes PII data through this API that is vulnerable. And this API is using this open source dependency with RC. And all of them are related to the same code module that is high business impact because it transfers money. And then this code module is actually part of a code repository that is being built and delivered to the cloud through the malicious CI/CD pipeline or through other mechanisms. And this is the actual context that we are generating in Apiiro. This is the core differentiator that allows us to make sense from all the cacophony or contextless alerts that you have from all the other tools. And what we learned in the last almost 4 years by analyzing a lot of data around a lot of customers is that AppSec teams invest 75% triaging their backlog and more than 50 days to fix critical risks in modern applications. This is why Gartner invented the new term and the new technology involved ASPM, Application Security Posture Management. What Gartner are saying is that you need one platform that will orchestrate all your existing AppSec tools, will map and measure the coverage of these tools, correlate the alerts, and prioritize and triage them in one place based on the root cause analysis of these tools. Not just aggregate the rules, or sorry, the alerts based on CVSS score number or their title, but the root cause analysis of these alerts. And lastly, close the remediation loop and manage the risk of these alerts. I don't care if I have a CVSS score 10 if it's not in a high business impact application that exposed to the internet and has or contains sensitive data of the organization. But what's missing? What's missing is a deep understanding of the application architecture. So what we developed in Apiiro is a layer of application inventory. We connect to your source control manager via read-only API, and between 30 minutes to an hour, we map all the code components that you have in the code. All the APIs, the dependencies, the data models, the data access objects, the frameworks like authentication, authorization, encryption, and we correlate them on a graph. So you can ask any question like, show me all the APIs in my code in Java in version 19 that exposes sensitive data in a high business impact application. So this is the first layer that we've built. We called it the risk graph, which augment all the data and allow you to ask questions. Hopefully I will have time to show it to you. The next layer is we connect all, like ASPM, classic ASPM, we connect all your existing tools to Apiiro. But now we can say, this alert from the SCA, this alert from the SAST, and this alert from the container is the same work item for remediation. But on the other hand, and this is the key differentiator from the classic ASPM, we have our own built-in solutions in the platform. SAST and secrets detection and API security testing and CI/CD security solutions. But we treat our third-party integrations and solutions, built-in solutions, as first-class citizens in Apiiro. And lastly, we built a risk control plane where you can define policies and say, you cannot use these encryption frameworks in my organization, and I will block the pull request or the build pipeline if you are violating my governance, my organizational governance. Or you cannot expose sensitive data through these APIs. And this is what we've built beyond the ASPM. I just want to emphasize one thing. It's easy to connect to other tools and aggregate the data and allow you to filter across the data. It's very hard to analyze the code and build and translate the code into a meaningful components and the relationship between them. This is what gives us the ability to take all the alerts and make sense of them, and I will show in the demo. This results, and you can see in a Fortune 100 financial organization, we reduced the backlog by 80%. GSoft are saying that we saved more than 65 hours, which are equivalent to 8 developers in their organization. And lastly, we helped an energy company in the Fortune 50 to reduce the mean time to remediation of Log4j by tying it to every code component, understand where it's deployed, and tie to a code owner that can actually fix it. So let's see a quick demo. So first, what I will show you here is the ability to measure the risk across your business units and across your application profiles. So you can see the open risk, the detected versus closed. We measure the mean time to remediation for every type, across the organization and every type of risk, like open source, secrets, and API security. You can see the top repositories with high and critical risks, and you can see the material changes versus the commits which actually emphasize the amount, the development velocity versus the risks that your developers are introducing. So here you can see that we had 148 commits, but only 2 risky changes. It means that you can trigger a pen test or a threat model or other processes as well based on these 2 risky changes and not all the others. And then what we can see is that when we connected all the tools into Apiiro, we have 200,000 alerts in our backlog. There is no AppSec team or development team that can actually take action and fix these alerts. So we can filter and say, show me only the alerts that are in the main branch, which are in production or already deployed. Show me only these that are related to a high business impact applications, which we automatically identify. Show me only the high and critical and high risks, not based on a CVSS score, but based on a multidimensional risk analysis. And lastly, again, we can go on and on and on across all the contexts that we generate, but only these that are internet exposed or maybe filtered by the category of the risk, like access control or your source control manager, API risks, open source security risks. And then you can see that we cut the backlog by more than 90%. And for every application, for every alert, we actually identify the evidence or collect all the evidence around this risk. We provide you recommendation actions, and we tie every risk to a code owner. So you don't need to go and ask around who is the right person to fix this alert. And lastly, we track the timeline of who changed it, when, who opened the ticket, and so on and so forth. And lastly, it's not only that you can go to the source control manager and understand where is it in a specific line of code or a code module, you can also see where it's running in your Kubernetes environment. So we map a code container, a container to a CI/CD pipeline, to a code repo, to a code component, to the code owner. And then we tell you the story across the software supply chain. Lastly, what we just released at RSA is the ability to query our risk graph. So what we built, as I said, we built an abstraction layer on top of the code. So all the APIs, serverless functions, protobuf services, all the dependencies, licenses, secrets, sensitive data in the code, data model, data access object, and you can query all the relationship between these code components. So for example, let's take this one, new PII that is written into a log file. So you can run the query and across all your code bases and pipeline identify it. You want to see all the high impact vulnerable dependencies or sensitive logging and monitoring frameworks in your code bases, or where do I have exposure of PII data in my code modules. And this is the power of the risk graph that we built that allow you to actually understand what you have across all the code components, across the developer knowledge, and tie it back to a code owner to reduce the remediation time by more than 80%. Thank you very much. If you want, we have a booth. You can see a deep dive demo, or ask me any question after this talk. Thank you.